Sure your phones, everything is put away, okay? No distractions now. Pay attention. In Intro to Applied and Pre-Cal, that's the course IAPR. Some of you took it, some of you maybe not. We talked about primary trig ratios. So sine, cosine, tan, right? So maybe some of your teachers, this is how I would teach it there. I'm saying sine is opposite over hypotenuse. Cosine involves the adjacent of the hypotenuse. Tangent involves the opposite and the adjacent. And if that doesn't mean anything to you, I have good news for you. You'll be fine in this course, right? And then we also use the inverse operations to figure out the angles, okay? I'm going to take a little twist. This still works, folks. This still works for right triangles. And maybe sometimes I'll throw it in there, but not at the beginning. I'm not going to mix them up. So the primary trig ratios only work with right triangles. In grade 11 applied, that's the code for this course, we will learn to solve for oblique triangles. So it means any triangles you can think of. Okay, so just a little reminder. In grade 10, if you are sitting, if this is the reference angle right here, so you can like shade this one in, then this would be the opposite side. The one that's across the 90-degree angle would be called the hypotenuse, and this would be called the adjacent, okay? Adjacent side. We can use SOHCAHTOA with this. With that scenario, sorry, what happened there? But oblique is anything but, any triangle that isn't right, a right triangle is an oblique triangle, so you may have, right, an acute triangle like this, or you might have one that looks like that, right? You've got an obtuse there, one angle that's greater than 90, okay? So an acute triangle, all angles are less than 90. That makes a triangle an acute triangle. Obtuse, you have one angle larger than 90, and immediately it turns into an obtuse triangle, okay? And this one, okay? The right triangle, you have a 90. You can use sine law and cosine law. So these are the only two that you're going to need to solve any problem that I throw at you, okay? So this is in the past. Now we can use sine law, cosine law to solve anything we want. We're going to start with the sine law today. And don't forget about your equilateral triangles, your isosceles triangles. They're still all there. What's the one where all sides are different, all angles are different? Scalene, right? Scalene. Okay, the sine law states this. So this is where the formula is going to go in, and I'm going to have a triangle that goes with it. So I'm going to make it look like a roof where one side is longer than the other. And I'm going to give it angles ABC. And when you have formulas with letters, it's just in general, that's what that means. So we have for the corners themselves, or the angles that are formed there, we use capital letters. And the convention has it that if this is angle A right here, then what do we call the side across from that angle? Lowercase a, okay? If this is capital B, then the side, if you travel across, the side that's opposite to it is called lowercase b. If this is C, then that's lowercase c. That's just convention. We will call it something else down the road. We might say ABC is the angles you're given and you're trying to solve for this side. You might want to call it X. That's fine. But if nothing else, this is what we normally do. Sine law states this. that if you were to go and take sine of angle A and divide it by the side that's across from it, that would be exactly the same as taking sine of angle B, this angle, and dividing it by the side that's across from it, so that'd be side B. And that in turn would tell us that if you take sine of angle C and divide it by side C, these ratios would all be the same, okay? I use this format all the time. Alternatively, you can flip this whole thing where you have all the sines at the bottom and the sides at the top. So we'll do that. So some textbooks will say, hey, you can also use this format. And that is, I will say I prefer this one, so I'm going to box this in. This is the one I would say the sine law states that this is true, and we can use this fact to solve for missing sides or angles. So let's put this law to the test, okay? I have, below all of this, I have a triangle that's actually drawn to scale, okay? Have you ever heard of GeoGebra? Yeah, I used it to make this triangle. So this is actually drawn to scale. So let's take, so if this is true, this is what it's claiming. Please don't get fixated with the letters. I want you to see the pattern, right? Sine of angle A, right, divided by the side that's across from it. That's the important part, because this could be sine of angle X. You would want the side that's across from angle X down here, right? That's important. You pair them up. Is that true? So let's try this. Sine of A, which is in this case 22.7 degrees, divided by the side length across from it is 3.74. Sine of angle B, what kind of a triangle is this? It's scalene and it's obtuse, right? Because you've got one angle bigger than 90. Okay. Just a reminder. So this would be over 9.51. And sine of C, 55.9 divided by 8.03. So obviously, if they're equal signs, we're expecting all of these to be the same. So let's check that real quick. This is calculator check-in time. See if you know how to use it. Before we're going to start, yours may have been used by grade 12 students in the past. So they changed some settings. So what you want to do is you want to turn it on first. I want everybody to be with me on this one. I don't know if yours says radian up here. If yours says degree up there, you're actually fine. You don't need to change a setting, but mine says radian. I would encourage everybody just follow what I'm doing just in case. So you press mode, press the button mode, and you want to go to maybe the fourth line where you have the options of degrees or radians. I'm going to go over to degree, hit enter, and so you want degrees to be selected. And then at the top of your screen, you'll see that it's in degrees, or else you'll get a completely different answer. Okay, so that's important, the setting. Once you've done that, you can quit this. So you go second mode, you go back to your home screen. Now let's try this. So we're going to go sine of 22.7, close the bracket there, and divide it by 3.74. And we're going to go 0.10318, and that keeps going. And now we're going to try the middle, sine of 101.39. Oops, close that bracket, divided by 9.51. You get 0.103081, and that keeps going. So far we're doing good. You notice, though, if you look at the answers, it's slightly off, right? It's slightly off. Should have actually rounded it to 4, maybe. 1.03081. And that's because I had to round the side lengths, right? When I actually copied this from GeoGebra, I had to round it. I couldn't use all decimals. So that's why you're off a little bit, but we're not going to worry about that too much. And the last one, sine of 55.9 divided by 8.03. So that's pretty close. We just have a check mark here. Did you know that if you were to do this and you don't have them equal, then this triangle actually doesn't exist? This is one way to prove whether or not a triangle is possible. So let's say you had no diagram, I just gave you a bunch of angles and sides. If you were to do this, you should have them all the same, or else it doesn't exist. Okay, the triangle is not possible to make that triangle. So, when can you use the sine law? Let's go to page 3 here. I want you to remember this for sine law. For sine law to work, you need at least one pair. Okay, that means that you need a known side and the angle that's opposite to it. You know without a shadow of a doubt that this is sine law, guys, because you're going to have to pick between cosine law and sine law. The sine law works in the following cases. When given two angles, so this is just a note here, when given two angles, make sure you find the third one before you continue. I'm going to emphasize that. Before we do anything else, make sure you always find the third angle. So you have this scenario, watch this. Just draw a triangle. It's the case where I give you two angles and I give you the side that's across one of those angles. So a check mark on the corners, knowing that there's two angles given, and you realize that one of them has a pair. Okay, we call this, I'm not too keen on this, I'm not going to test you on it, but it's angle side. Okay. Then you've got the scenario where I give you two sides, any two sides. Okay, I'm going to stick with these two here. And you know the angle across one of them. So you either know this one or this one. That will depend on the scenario when you draw your triangle. Okay, so you've got a pair there. This one is called SSA. You can spell it the other way, but then I'm in trouble, right, with that one. ASA is the next one. Okay, so ASA, how does that work? Emphasis on that the side is in between the two angles. Emphasis on that. So let's say you have the angle here and you have the angle there and you have that side that's in between those two angles. Now let's go back to the beginning here. Did you have a pair here? That's your pair. That's what I mean with pair. Okay. Did you have a pair in this scenario? Yes. You had a pair. Do you have a pair in this one? Not at first glance. But what did I tell you when you have two angles? Can you find a third one? Okay. So I'll say this. Find third angle to get pair. So it's like a hidden pair. It's the couple that hasn't announced it yet that they're together, you know what I mean? Still on the down low. hidden pair. So you need to do a little bit of extra work to find that third angle, and so we're gonna use a color. Okay, that is something that we solve for, and now you have your pair, correct? There's your pair. So you have the angle, that'll be a number, and you've got the side length, that'll also be a number down the road. So if you notice that there's a pair possible, it is sine law guaranteed, okay? No doubt about that. Okay, keep going. Remember, these letter formations I'm not too interested in. I will use SSA later. It'll come back. That one I do, there's a special case with that one. There's a problem we run into, but you're not going to worry about that problem just yet. Okay, next, recall. You should be able to determine if your answer is reasonable, right? So you should see that the largest angle is across the longest side. Like if you solve the triangle, you should see that pattern. And at the same time, the smallest angle should be across the shortest side. Sometimes students are like, I solved it all, and then you can tell right away it doesn't add up, right? Okay. And the middlest angle should be across the middlest side. I just made that one up. But that's obviously, right? Like we just focus on the largest and the smallest, and the other one should take care of itself. Yeah, drawing and labeling a triangle. So if I ever give this to you like this, this is the triangle DEF that you're talking about. You've got an angle, a side, another angle, and a side. Do you notice something about angle D and side D? What do we know about these two? That's a pair. They're across from each other, right? The angle and the side, you know right away they're going to be across from each other. So, if I ask you to draw it, I'm not going to check whether or not you drew it to scale. I just want the letters, so this will be D, E, F. Mr. Dirksen, does it matter if I start D here? Or do I need to stop up? Like, where do I start? It doesn't matter where you start. Just go clockwise once you start, okay? So if I start with D up here, just go D, E, F, right? Just go clockwise, it works. Even if you go counterclockwise, you'll be fine. I know your teachers told you when you were younger, always go clockwise, it doesn't matter. D is 60 degrees, so you fill that in. Side D is the whole side length, that's 5.2 centimeters, it's across. Angle F is going to be 80 degrees, and side F is 8.3 centimeters over here. Okay. All right, so that's just a little reminder. Let's go and actually use this to solve for a missing side. So let's go to page 4. Notation is going to be important in this unit, so make sure you use the proper notation. So we're going to start off with using the sine law to solve for sides. So you've got this triangle, you already have a diagram. You notice that this angle is across a side that you know, so we call that our pair. Okay, that's what I call a pair. So I start with that. You know it's going to be sine law. Why? Because there's a pair. You've already determined that. So you start with the pair. Watch this. I go sine of 62 degrees over the side length, 4.5 meters. And you want to solve for side B, correct? Side B is where? It's this one right here. What do you need to solve for side B? The angle across from it, correct? Do I know it at the moment? Am I able to get it? Am I able to find that angle? I've got two angles, so yes, I can find it. So if you notice that, find angle B. You go 180 minus 38 minus 62. And that's 80 degrees. And I'm going to underline this with a red pen. I'm just going to say, in this triangle, I had to do a little bit of extra work to find that angle. Okay. So, to find side B, we would go sine of 80 degrees. I'm going to use that red pen if you have a color. And that will allow you to solve for the side across from it. There's always a pattern, opposites, right? Angle should be opposite to the side. Angle 80, right, which is angle B, should be opposite to side B, which you're trying to solve, right? They're paired up like that. What does this look like? Proportional reasoning? Okay, so what do? You go to the side where the variable is. So you would multiply this times that. You multiply. Can we turn that off, please? This times that divided by that. So you go sine of 80, right? You multiply that whole thing by 4.5. And then you divide by sine of 62 degrees. These are all numbers, guys. These are all numbers. So don't be thrown off by that. So grab your calculators and let's enter this and see if you can get the same answer as I am getting. So sine of 80 degrees. Make sure you close the bracket. I don't know what happens if you don't close the bracket. My gut tells me that you're gonna get the wrong answer if you don't close the bracket. So you go times 4.5. So I figure out what the multiplication is first. I hit enter at that point, and then I just go divide it by sine of 62. And so you should get 5.02 meters. We're in meters, right? So make sure your units are there, and you clearly indicate that that's what you solved for. I will use this to do another example. So if you have room yet, what about side C? What if I ask you to solve for side C? You see that pair that I started with? Once I determine that, I stick with it. So I'll just start with that again. Sine of 62 degrees over 4.5 meters. What goes here? Definitely sine. Okay, some students just put the angle there. Like earlier, they would have just put 80 there. That's when you're still learning, right? But an angle should always be attached to sine in this case, okay? So sine of what? What would go here? Wait a minute. We're solving for side A, okay? We already know side C, it's 4.5. So let's change this to an A. Easy, easy. So to solve for side A, I would have to use angle 38, right? And that's going to allow me to solve for side C. This is C up here on the triangle, if you want to go ahead and label that. So to figure out side C, we simply go sine of 38 times 4.5 divided by sine of 62. Thank you. Apparently, I'm not sure what I'm doing here. We're solving for side A, okay, folks? My bad. So it's A here, it's A there, it's A there, okay? So all of them turn into A. So now we multiply this and divide it by sine of 62. So try it. I was just making sure you're paying attention. So it's 3.137. So we round that to 1/4. Okay, angles and side lengths rounded to 2 decimals. Okay, So forget whoever taught you angles get rounded to a full number. Forget about that, okay? Because grade 12 provincial exam, they expect you to round everything to 2 decimals at the end, okay? All right, so why don't you give this a try? What did we just do now, folks? If you know all sides and all angles, it's called we solve the triangle. So if the question ever says solve the triangle, you solve for all sides, all angles, okay? I'm just going to leave it for now. Can you try solving this triangle? So start with figuring out side A, and then solve for whatever other side is still missing. Give it a try. Is there a pair? If not, is it a hidden pair? And so try to get that started. See how it went? No pair at first, but I've got 2 angles, so solve for angle C. $95, $65, right? So this is important, but it's not the answer yet, right? So we plug that in here, and you've got your pair. So some students find it confusing. What do you mean with the pair, right? I mean this angle, like that number, and the side that's across from it, which is also a number. So you need to know both of them to call that a pair. The pair that I'm talking about here. So we would go sine of 65 degrees over 14.5 meters. And then if you want to solve for side A, you got to use angle A, right, to solve for this. That's what you want. You have options here. You got to pick the 30, okay? And so that's side A across from it. So you go A is equal to this times this divided by that. So it's sine of 30 times 14.5 divided by sine of 65. So you multiply and divide, you get 8, right? I think it rounds to 8 meters exactly. And so there you have that. If you want to solve for side B, this one, you start with the same pair. That's what I would recommend. And then we go sine of 85 over side B. Okay, and then you cross multiply and divide, so it's sine of 85 times 14.5 divided by sine of 65, right? Cross multiply and divide, and B is 15.94 meters. Okay, so that's how you solve. Triangle solved, that's what you can write down here. Triangle solved. If you solve for everything, then you solve the triangle. Another thing here, let's check, is our largest angle across the longest side? So what's the largest angle? 85, right? We should have the longest side across from it. So we check all the sides. We've got 14.5, 8, and 15.95, so it does check out. And the smallest angle should have the shortest side across from it. 30 is the smallest angle. 8, which is across, is the shortest side, so we're doing good. Okay. Is there something else I want to mention here? Oh, look up here, make sure you understand this. I want you to understand it. I know you can like follow instructions, but could I have used, because once you solve for side A, you've got another pair, right? You've got 30 and 8, correct? Could I have used that pair to get me started here? Yeah. The reason I would discourage you from doing it is because if you made a mistake here, it's going to transfer over to this one. But if you just stick with the pair that the question kind of gives you, then there's a better chance of getting this one right. So that's why I would discourage you from doing that. Okay. Let's solve for angles here. And then you're going to have some practice time because you're going to have to decide what's happening here. So watch the, so if you're using the sine law to solve for angles, we have to use that inverse operation. So let's see here. Triangle XYZ has the following dimensions. You've got side, another side, you've got an angle. Can you tell that there's going to be a pair here just by looking at the areas and saying, yep, I see side X, angle X. Okay? This is a pair. Therefore, I'm going to use sine law, because remember, there's going to be a point where you're going to have to decide, and sometimes you won't see it until you graph it, and that's fine. Okay? So sketch the triangle, then calculate angles Z and Y. So let's do that. Just make sure you don't make it look like a right triangle, because most of the time it will not be a right triangle. I know you missed them, right? But and then X, Y, Z. So start somewhere. I'll start X, Y, Z. I'll use capital letters, and I will put the 34 degrees in here. Side X is 6.2 centimeters. Side Z, where is Z at? If angle Z is here, then this is 3 centimeters, right? So you just got to know where to put everything. Do you have a pair? Yep, we do have a pair. It's visible here, which is great. That means we're going to use sine law to solve for this. Where am I going to do this? I'm going to do it right underneath the triangle. So same as before. You start with your pair. You stack them like this. And on the other side, which angle would make more sense to start solving for? If you have this side, then this is the only angle you can solve for right now. Okay? You always need things across from each other, because Y, that angle doesn't have the side yet across from it. So this is the only one that makes sense. So sine of Z over 3 centimeters. And this is still proportional reasoning. That's how sine law is unique. So we're going to solve for angle Z, but not yet. Okay? You got to keep them together like this. Sine of Z, that's our unknown. You start with the number, multiply across like that. Okay? And then we divide by what's left. So we go 3, okay, times sine of 34 divided by 6.2 centimeters. And normally we don't like trains in math, but it's okay to do it here because they are all the same. So let's plug this in and see what we get. 3 times sine of 34. I'm going to hit enter. Then I go divide by 6.2. That's 0.27. It keeps going. Don't clear your screen. Leave it right there. Okay, I'm just going to write down the first couple. Okay, so you're saying I'm going to use all decimals here. So this is your last step. Angle Z is going to be sine inverse of that. Sine inverse is basically like when you square root both sides. When we take the inverse of both sides, we get rid of the sine on the left side. And so basically we're taking the inverse, it's the opposite operation of that decimal. So this is how you have to do that. Once you've written that down, we do this. You press second on your calculator, you press second, and then go to sine. There's a sine button right here where my pencil is hovering. Right? So you see that inverse. And then you just copy paste, so you can't see that there. Just go up, copy that number into that bracket. You can close it, you don't have to close it. and then hit enter. And so that is your angle. What would that round to? 15.70, right? So this is 15.70 degrees. You solve for angle Z. How could I solve for angle Y now that I have two angles? Now we have two angles. Okay, so we're going to go angle Y, the one we're missing, is 180 minus 34 minus 15.70. And if you do that, you get 130.3 degrees. So just a note, we have an obtuse triangle and a scalene triangle. Why is it obtuse? Is because there's one angle bigger than 90. Scalene, all sides are different. How do you know that all sides are going to be different, folks? Because all angles, every single angle is different, so every side length will also be different for that reason. Okay? It's just how it goes. But we're not done yet. What if it asked you solve for side Y? Underneath here we've got solve for side Y now. We're going back to solving for sides. I'm going to start with my pair. The pair that I started off with, right? At the top here. Copy that down. You're going to go sine of what? If you want to solve for side Y, what angle do you need here? You need angle Y. We have it now. It's 130.3. So now I'm mixing it up, right? I'm doing angles, then I'm solving for sides. So Y is equal to 6.2 times sine of 130.3. So I just multiply these two. And then you divide by sine of 34. If you do that, you get 8.46. And we are in centimeters. Oh, calculate the perimeter of triangle XYZ. What is the perimeter again? Distance around. I hope you remember that. So it's basically just x plus y plus z, right? Just add them all up. I thought I had the answer to that. Oh, there it is. It's 17.66 centimeters. Could you find the area of this triangle? Not at the moment. You need the height. We'll do that down the road. Okay, I'm going to stop here for now. And I'm going to ask you to try pages. For now, we're just going to take it to page 9 maybe. So pages 7 to 9. So I'll write that down at the bottom of this. Try page 7 to 9. Given that tomorrow is a day off, guys, please use the rest of the class to work through these so you can kind of like ingrain it so it's stuck. Okay? So, and I'm going to walk around in a bit. I'm going to let you get started, and then we'll see how you're doing. And I'll look for the answer key as well.